So in this video, we're just going to focus on computing the probability of D happening, which is what we're looking for in this problem. So what is the probability of D? So what I've done here is I've created a tree diagram where the three events that are given to us, A, B, and C, are listed here along the first part of the tree diagram, moving from left to right. So these are the only three events that can happen, and the probabilities of each of these three are going to add up to 1. So we know, for example, that the probability of C is 0.22. So let's go ahead and put that onto our diagram. We can write that this way: probability of C is equal to 0.22. So let me write this. Sorry, I have my mouse today, not my iPad. The probability of B is 0.67. So the probability of B is going to be over here on this branch. So the probability of B is equal to 0.67. Now, we're not given the probability of A. We're only given the probability of C and the probability of B. But because A, B, and C are the only three events for this first variable that we are considering, then we can find the probability of A by using the fact that the sum of the probability of A, B, and C have to be equal to 1. So 0.22 plus 0.67, which is 0.89, would leave us a remaining probability for A of 0.11. And we can check that. 0.11 plus 0.67 is 0.78. 0.78 plus 0.22 is indeed 1. So the sum of these three branches have to add up to 1. We're also given the probability that D does not happen. Let's go back here. The probability that D does not happen given A is 0.89. So notice that we're being told that A happens. So the branch that we care about is the one on the top. So given that A happens, okay, we stop there. Then we're looking at the probability of D not happening. So that's going to be down here onto this branch. So I'm going to mark this with the probability of D complement given A is 0.89. So let's go ahead and do that here. I don't have enough room to write the notation, so we'll just write the numbers. We also know the probability of D given B. So the probability of D given B. So now we're given that B happens, and we're looking at the probability of D happening, and we're told that that's 0.53. So we'll put that probability on its appropriate branch. And then finally, we have the probability of D given C. So we are given that C happens, and we're also given that the probability of D happening, given that C has happened, is 0.37. So we're going to put that on our diagram. Now, we've got three probabilities that are missing. The sum of these two probabilities emanating from the event A have to add up to 1. So this has to be 0.11, right? Because D happens or it doesn't happen. Those are the only two possibilities after A has happened. So the sum of these two, D and its complement, have to be 1. It's also a basic rule of probability. That means that this one here is 0.47. This one here is 0.63. All right, we've filled out the entire diagram now. So now we should be able to compute the probability of D, which is what we're looking for. So what we want to keep in mind is that on the diagram, there's three different ways that you can get to D. You can get to D right here by coming out of this branch, right here coming out of this second branch, and down here coming out of this third branch. So to come out of this first branch up here, we would go through A and then through D. So we're going to multiply these two probabilities here to get the first piece or the first way that D can happen. So if we were to write this out, we've got three pieces that contribute to the probability of D happening. If D is going to happen, it's either because A has happened first, or B has happened first, or C has happened first. Because these three events are disjoint, the probabilities of each of them happening and then D happening are also going to be, shall we say, separate. So if we're focused just on this first branch here, coming up through A, then what we're doing is we're taking, for the first piece, we're going to take the probability of A, which is 0.11. So let's go ahead and put that here. So 0.11 multiplied by the probability of D, given that A has happened, which also happens to be 0.11. The second way this can happen is right here going through B. So the probability of B is 0.67. So we're going to do 0.67, and then we're going to multiply that by the branch that then leads to D, which is 0.53. All right, so then we're going to do this. And of course, we've got one more way that we can get through D. That's first to go through C. The probability of C happening is 0.22. And then we're going to multiply that by the probability of D happening, given that C has already happened, which is 0.37. So when you add all of these three numbers up after you do the calculations very carefully on the calculator, then that's going to give you the probability of D.